microprocessor. In other words, a mini computer, plus peripherals integrated into a single chip, and that allows it to sense the outside world and use its outputs to drive small external loads. You got it now, right? That's the technical definition, description of an Arduino. Now, another thing nice thing to know about Arduino when we're just getting started here is it does not use any operating system. It doesn't use Linux, Windows, iOS, Android, none of that stuff. You program it simply by using a programming language called C++. We'll talk a little bit more about that later. So there's a wonderful side to this thing. All right. Now, an Arduino was originally developed in Italy in 2004. So by the technical world, by the computer world, it's an ancient little piece of equipment. However, it was so well designed, it was originally designed to teach students how to program. It would teach them code. In other words, how to program something in C++. So somebody in Italy designed this card to do just that. It was a teaching aid. Well, the robot and experimenter world grabbed onto this thing, and in those 15 years, it's gone crazy. Because the good folks that invented it were kind enough to leave it open source. In other words, nobody owns it, nobody has the rights to it. Anyone can build one if you're equipped enough, and it can be programmed by anyone, and all those programs remain open source also. There's dozens of add-ons and thousands of programs called sketches in the Arduino world that are available on the internet. And I'm not kidding when I say thousands. It is incredible. And many, many of those are for model railroad. This is an Arduino. In this case, it's a version of an Arduino called the Uno. Far and away the most popular. It's the easiest probably of all of them to handle, to deal with. It has the computing power of an old Commodore 64. So it doesn't sound too impressive. It has a grand memory of 64K, right? Not megabytes, K. But it is amazing when you get into the programs and see what these people are able to do with that C++ language in one of these. Now the Arduino family has several different versions of this. This being, like I said, far and away, this is the HO scale of the Arduino world, okay, if you want to look at it that way. This is the N scale of the Arduino world.
Wow.
Aptly named the Nano. There's also a Mega, which is bigger than this one and a little more memory, a little bit more capable. There's also a Mini in between these two. All right? Now, most of the time, the same program will work on all of them. The advantage to this one, obviously, is the size. When you're dealing with model railroading, for instance, it's easy to hide this in something or under something a little easier than it is these. Besides, as we will see in a minute, this costs anywhere from $7 to $11. That's it. Wow. All right? This is about $2 or $3. So if you're going to make like signaling, for instance, and you have these signaling nodes all over a big railroad, you probably want to use one of these rather than a whole bunch of these. So the Arduino is actually a family of computers, but most are microcontrollers, but most of the time, the people, when they say Arduino, they're referring to this one called the Uno. All right, big deal. I've been talking about all the things it can do. So what can it do model railroading wise? Some of the uses. Crossing flasher gate controller, traffic light sequencer, a flare fusee simulator, chase lights, like on a building sign or something, campfire or a whole building on fire, an arc welding simulator, emergency vehicle flashing, an animation controller, and I mean animation. I saw one online here not too long ago. It was an HO guy chopping at a tree, and it had the guy animated, so he took about 6 or 8 licks at this tree, and then the whole tree fell over. Okay, kind of cool little thing, you know, and it was all done with one of these. Back and forth shuttle for a train, strobe light, lightning like in a storm, infrared or optic or current train detector. Any way you want to detect a train, you can do it with an Uno and some extra pieces, of course. A defect detector simulator like they have on modern railroads now. A scale simulator. Tom Gunther's building one of these for his railroad. Oh, Tom Gunther and others.
Tom Gunther's building one for my railroad.
Oh, he's building one for your railroad. Oh, okay. Hey, I saw one. I know Tom's not doing this. He has a deal where it puts up a simulated weight. I saw one using one of these the other day where they actually cut notches in the bottom of the rail. And it has I don't know where they got it, a pressure pad about that big that slides under the track, and it actually picks up the weight of the car and adds 10,000 to it. and you actually are weighing these cars using this scale track. But anyway, it's just a relay controller, turntable control. It'll run a stepper motor. And you can run a turntable with one, a fast clock, turnout control, yard ladder control. The Southern Indiana guys have a yard ladder controller running off of an Arduino. The gentleman over there, I forget which guy did it, but he used an Arduino and programmed it so you have routing through the yard using an Arduino. Bridge animation, make it swing or lift or whatever you want to do. Signal system logic, you run a whole signal system on a railroad, a model railroad with it. Semaphore animator, so you can use a stepper motor to run a semaphore up and down. DCC stationary decoders for running things like turnouts and such. A jib crane or a coal loader, once again part of the animation deal. You can make a jib crane go in any axis you want. Semaphore, sound effects. You can use one of these. It's an add-on. It reads a micro SD card. You can put files on the micro card, program or build this into your system with the Uno, and it will play what's on the SD card, micro SD card. And Lord knows what else is out there. Yeah, Karen?
Question. What do you plug those into? Your computer?
Yes, and as you will see here in a minute, I have a little demonstration here later. You program it using your computer. Yeah, we haven't got that far yet, but yeah, it's a legit question. You program it, it plugs in using a USB cable right into the connector on the side of the Arduino. Uses what most of us call a printer USB cable or a B cable, I think it is, to connect to the computer. You upload the program from the computer into the Arduino, and then it'll run off of all kinds of stuff. It's amazing. I'll show you that in a minute.
Thank you.
But anyway, it's you know, your imagination will be what takes you wherever. All right, like I said at the beginning, so why should I care? Because most of what I just mentioned a moment ago is available. You can buy whatever to run, build most all that stuff I mentioned a little while ago. There's already companies out there that make that stuff. So what's the big deal? Well, a couple of the reasons why. Because Arduinos are cheap, right? And they're available. They're out there. You can buy them. You can buy them at Amazon by the buckets full. They can be customized to your railroad needs. You need a special kind of signal system, or you want it to do this. Maybe it's not exactly prototypical, but what you want on your world, you can make it. Maybe a way to get youth into the hobby, another technical thing here. Fits in with other high-tech innovations we're using, like laser cutting and 3D printing and other things like that. This kind of slides right in that category. Or you could just plain old wow others with your inner geek, okay? You know, that you did it instead of going out and buying it, okay? For instance, cost comparison for building a crossing flasher controller, right? You can go to Circuitron and buy one right now. Cost you $45.95. And in fairness of advertising, you can buy one from Walters for $30. The Circuitron one's only unidirectional, by the way. You can get an Arduino Uno, just like I showed you, this one right here. You can buy them online for anywhere from $7 to $11 each. Photo resistors, that's the optical detector, goes in the track. You can get those for a grand total of 14 cents a piece, all right? Or actually 7 cents a piece. 14 for 2 of them. We're big bucks here. The software is free, so you spend about $10 in your time. And then, of course, that's for the controller. That doesn't count with the stuff you see on top of the layout. I'm talking about the under layout stuff. You put anything up there from cheap plastic to high dollar brass, whatever you want for the above surface, that's a different category. I'm talking about the controller part, the under the table part that you don't see that makes it work. Or even an arc welder simulator. A lot of people have it. Some guy somewhere in a garage or inside a car shop or whatever welding, they have the little flash going on. Well, Circuitron again sells that. It sells an AW2. Costs you $26.95. Once again, you start with the Uno, 7 to 11, white / blue LEDs. That's usually how you do it. You use a combination of white and blue to give it that welder look. 50 cents. Software, free. Costs you $10.50 to do an arc welder simulator or thereabouts. So, you can see, pricing-wise, there's no comparison. It's way cheaper than buying it pre-done. Now, the hardware, and we'll switch sides here, guys. The hardware in the Arduino world, we'll call it. I mentioned the Uno, 7 to 11. The Nano is $3 or $4 here again, depending on who you buy it from, that sort of thing. There's a lot of shields. Now, what's a shield? Excuse me for stepping in front here. The Arduino, as it is pretty talented, but it can't do everything. So people have come up with add-ons to go directly, literally, on top of the Arduino, and you just stack them up depending on what specific task you want to do. You can do all kinds of things with these. The Arduino can only handle an output of about 400 milliamps. It'll run several LEDs, maybe even one of these 9-gram servos, but not very many of those. So you add on a shield, in this case a motor control, and it piggybacks. Pull this foam off. You see, hopefully you can see there's 2 rows of pins there. Well, those rows of pins go directly in these rows of sockets on the Arduino, and then they are now electrically coupled together. The motor control has its own electrical input and output. So you can run, in this case, you can run up to 2 amps through this thing to run something that takes more current than this. But all the control comes through your programming that's in this. So you add a shield, it's called, it's add-on circuit board, based on what you're trying to do. And there's several things out there. I showed you the micro SD one. This is a little baby shield for sound. This is a motor one. This is one if you want to run a bunch of servos, like to do a crane or give me some other things.
Drawbridge.
Animation, drawbridges, that sort of thing.
Turnout.
You can run 19 servos off this thing at one time. The Arduino, you can put all the programming in it, and then this does all the grunt work as far as powering all the servos. The signal for which servo to go which direction comes from here. Once again, this just stacks on top of the Arduino. And that way you can multiply the power. Now, Karen asked about powering these things. Well, you can use these sort of things, which are power supplies. You can run 12 volts in and it'll put out the 5-6 volts. But in reality, the Arduino has a voltage regulator built into it. You can plug in here anything you want. Let me find it. You can stick a 9-volt battery on it, plug it right in here. It has a bayonet socket right there, just like any power supply has. You can use that for a 9-volt battery. I've got one here I'll show you in a little while. It's a regular wall wart that this one puts out 9 volts DC. It has to be DC in. But anywhere from like 5 volts to 12 volts, you just plug it in here and the voltage regulator takes care of it. You can even use, what do I do with it? A cell phone wall wart and a USB cable and plug it in here. And that'll work. Or you can just leave it hooked to your computer and it takes power from the computer through the USB cable. It is amazingly versatile, okay? It's hard to mess it up unless you put AC in it, and then you gotta buy another one. Or much over, I've seen a guy run a program where he was running one on 15 volts and it was working because he wanted that for a reason. But the point is that you can power these things with all kinds of stuff. And it takes so little power because it doesn't put out much that you can put a 9-volt battery on it, leave it on, and literally run it for days on one battery, okay? So it is very, very versatile. There are many other things. We haven't even talked about sensors yet, the ways for the Arduino to pick up stuff from the outside world. Things like infrared. This is an infrared sensor. You'll see more of those here in a little bit. These are infrared. I have a whole bag of optical sensors, better known as photoresistors. Those little bitty, look like flat light bulbs. They're not, but that's what they look like when they're in between the ties on your railroad that run. Yeah, it has a little squiggle line on top of it. You're right, Bob. But anyway, I got a whole bag of these. Cost me $5. Okay, and $5.75. 30 of them in here. If you need a photoresistor, let me know. The way to buy the Arduino when you start out, when you go on Amazon, which is where I've been getting this stuff, you'll see listed Arduino starter kits. Check those out. For less than 20 bucks, you get, obviously you get the Arduino, you get a box of LEDs, okay? A whole box of LEDs. You get about a bajillion resistors, okay? All various, they're all marked, all different resistance based on what you're doing, the voltage, what kind of LED or whatever it is you're trying to power. You get a nifty USB cable to hook it up. And depending on the starter kit, you get some of these shields too. Plus you get things like a proximity gauge. So if you get close to it, it starts the Arduino program up. Be kind of handy in a club situation or something. You have some animation in a certain area. You stick one of these in the fascia, somebody gets close, it starts up. Electric motor with this nifty noodle fan. But anyway, that came with it. All these things are for demonstration, for playing with the potentiometer. Even have a little baby joystick. I haven't fooled with that yet. My point is, if you buy the starter kit, you get a whole box full of stuff. and wires to hook it all together with, okay? These are called Dupont connectors. They just have a solid wire on the end, a solid pin on the end that plugs into these sockets on the boards, and also into the breadboard, which is what you use to figure out your program, make sure it works first. And then because you just plug into here, and then you jumper to this thing to that thing to that thing, zero soldering. That way you can figure out what you're doing is going to work, make it work like you want to, change the timing, change the resistance, change the sensitivity. You get all that worked out. Then, when you go to stick it under your layout, you get one of, come on. What happens when you spend too long with the computer trying to get it started. After you get it all prototyped and you're ready to install on your layout, you take one of these things and then you solder the stuff together, okay? So it looks neater, takes less space, not going to fall apart later, wiggle out on you, that kind of thing. So you just got all these holes and they're all lined with the metal. So you put the pins in there and then solder it on the back. So you get, I got a whole bag of these for a couple bucks. Called a prototype board. But this is a breadboard. This is what you play around with. So that's a quickie thing into the hardware side of the Arduino world. You want to do something, there's a shield out there, there's an extra board there already developed. It's online, or like I said, Amazon carries all this stuff. It's just, your jaw hangs open when you start looking for something with what all is there. So it's a lot of fun. Like I said, you name it, it's available. The optical sensors, resistors, LEDs, all that stuff is dirt cheap when you buy it online, and you get a bunch of it.
How much was that starter kit?
Starter kits are usually about 20 bucks. Now you can get crazy and get this, big boy starter kit's like 60 bucks. It's got, everything in it, but I don't really recommend that. Put your toe in the water first, 20 bucks is not much of an investment. And you get enough stuff that you can actually put something together. You can make things flash and light and do this, that, and the other, and without getting too deep into it till you're ready to get deep into it.
It comes with directions.
Well, I actually have over the last few months, I bought 2 starter kits simply because I wanted a second Uno. And the second kit had different stuff in it than the first kit. So I bought 2 starter kits. The second one I bought actually had a mini DVD in it that walked you through a bunch of stuff. Okay, it really did. It's quite good. In fact, it's still still in the computer. I forgot to take it out. The little, like I said, little baby DVD. But the first kit I got had not much in it. It told you what the different things were that were in the kit, and that's it. But I'm going to show you here in a minute, there's a lot of ways to figure all this out. And without getting into it too deeply, you got the Arduino world. Then there's something out there called a Raspberry Pi. And it's truly a computer. It has much more memory in it, much more capability. It's about a $40 piece. Everything but a monitor and a keyboard, and you have a really nice computer. But we won't talk about that now. Just know that it's out there also. Same idea, just a step up, as it were. All right, now the software side of the Arduino world is a whole different animal here. There are thousands, and I mean that, thousands of sketches. Those are what programs are called in the Arduino world. Sketches, ready to go. Somebody's already done the work for you, okay? If you don't believe me, just Google Arduino for model railroaders and then stand back, because it just goes, it's amazing. Now, the official Arduino website is where it all starts, where you keep coming back where you compile these programs, even though they're already put together, you download them from wherever you find them into this website, and then it compiles them for the Arduino, and then uploads them into the Arduino itself. Arduino.cc. There are tutorials on downloading, creating libraries. That's groups of these sketches. You put them in a library so you can keep track of them. Uploading to the Uno, all, etc. And it is really simple and not too geeky. I know nothing about programming in C++, and I mean that. I've learned some stuff by osmosis in the last couple, 3-4 months, but I went into this not caring to learn about C++, and I don't. There's no way I could sit down and write even a simple program. You know, unless you really want to, okay? And obviously, have at it. There's a lot of stuff online, tutorials for learning just that, about learning to actually program C++ for yourself. So the software is available, easy. This is a website, and this Arduino website, yeah, it's put together by nerds, but unlike the Digitrax information books, which are awful, this is quite easy to get through. It truly is. Don't be afraid of it. Just jump in there. That's what I did.
Can you run a train on this?
I'm getting to it, Joe.
Okay.
Yeah, so you go to this Arduino.cc website, you click on this software drop down at the top, and then downloads. And then you download this thing called the IDE, the Integrated Development Environment, which that's worthless to remember, but anyway, that's what IDE stands for. You put that IDE on your computer, and then that allows you to do this downloading and uploading like I was talking about. Once again, all easily explained on their website. Because that's, like I said, where you can import your sketches from other sources, because as you will find, these model train sketches are scattered all over the internet. But they all use the same format. They're all designed for the Arduino, so they will work. You just have to grab them wherever and download them into your computer, into this environment, and then you can then upload them using one of those USB cables from your computer into the Arduino. Once it's in there, it's there until you change it to something else. Doesn't matter, doesn't have to stay powered or anything else. Once you program the Arduino, it stays programmed. And then, like I said, most all of the programs will work with either the Uno, the Nano, the Mega, the whatever, in the Arduino family. They all use the same C++. Or you can just get your grandkid to help you out with it, okay? I mean, that might be a good grandpa, grandson, granddaughter kind of thing to do. All right, so hopefully you're kind of getting the hint now why you need to care about what these things are and what they're capable of doing. We are in no way today going to sit down and show you how to write a program or sketch, because I don't know how to do that either. But I'm trying to introduce you to the Arduino and what the heck it is and what it's capable of. There's no limit to what you can create, and chances are somebody's probably already done it anyway. All right? These things have been out for 15 years. So they've had a long time to write, rewrite, update, you know, all this stuff. Now, if there is a next time, if I do a Arduino Why Should I Care Part 2, two things I'm going to bring here live and show you is you can have a full DCC system for less than 45 bucks. All right? It would be a good thing to use like for a programming track because it uses JMRI. The $45 does not include your computer. Your computer has to be hooked up because you use Panel Pro, if you're familiar with JMRI, use the Panel Pro side of it to actually pull up the throttle to run the train. Use Decoder Pro to program your engines. We use it all the time at the K&I. But with an Arduino and two shields, you can have a fully functioning 2 to 3 amp DCC system. It will run a small layout, just like a Zephyr, Digitrax Zephyr, or the starter thing for NCE. Same kind of deal, and it will do that. And if we do have a part 2, then I'll have one here and I'll show you. Because I haven't done it yet. I've seen it done. Haven't done it yet. I don't have the correct shield, but it's on the way. And I have a little demonstration here of just lights, but next time I'll have a full tilt grade crossing, which will have gates, lights, bells, the whole deal, and work obviously from either direction, which this one will do. But that's as a perhaps maybe next time. Or you just look it up online yourself and do it. Don't wait on me. It really is, you know, the code is incredible. The people that write this code, the programming, consider how little space you have to work with and what all the code for a DCC system takes. They use up over half the memory of the Uno just in the programming. So the fact that they're able to throw 2 to 3 amps through another shield on top of it to get to the track and have all this JMRI stuff worked out so that it transfers that information. It's pretty amazing. It really is. So the stuff people are able to do, the true geeks. Any questions?
All this stuff comes through Amazon. Is there any one particular vendor?
Well, I bought from several, and obviously
Okay.
Amazon's not the only place. You can get it at the Radio Shack, what's still around.
As Mike says, it's open source, including the circuit boards, all that thing. So there are many manufacturers out there that make this. Right?
Yeah. See, the thing is that a lot of people make it. I have 2 of these, and they're by different people. You know, 2 Unos, 2 of these Arduinos, and they're made by entirely different people. They look exactly alike, except one of them is black. And I have a little quickie demonstration here. Maybe we'll turn it around so you can see all of them. See, here's a small breadboard here. See the white board with all the wires in it? And then here's the other Arduino. It's black, all right? Doesn't matter. Made by a different company, doesn't matter. They're all open source. In order to sell, though, with the Arduino name, it has to work a certain way, all right? Now, here again, I got this wall wart right here. I just want to double check. 9 volts, all right? 9 volt DC. I'm going to plug it in. And you can see that you can't see it, but anyway, see where the Arduino has the 2 lights on now. That means the power's there and the program is working. Now I have infrared sensors in this track, right? In my brilliance, I didn't make it long enough so I could put a car on here and actually roll a car across. The shortest car I own will still cover up the infrared to start with.
That's called a
okay?
learning
So,
curve, Mike.
not planned work at all, all right? But this is obviously a quickie anyway. All right, and then another sad story. See, I just have 2 little red LEDs here. I had some plastic crossing lights, cross bucks with lights. And in my infinite wisdom to try to improve this thing, I rewired some stuff and forgot the resistors. Plugged in the Uno and both traffic or crossing lights went. So I said, okay, scrap that idea. So anyway, hopefully I didn't jerk any wires loose or anything in the process here. Yeah, I did. Yeah, I did. Rough road. stuff has got to eat up.
Hello?
That's what you get when you're prototyping this stuff and just pinning it all together and it's not solid. Come on, Mike.
Well, there's a prototypical description for this. It's called a partial activation failure.
Is that what it is?
Happens all the time.
Not exactly flashing, is it?
It's flashing.
We'll take your word for it. The one's good.
All right. See, we have the infrared detectors here, and if I cover that one, it starts flashing. Train's going whatever. I cover this one, then I uncover it like the train just cleared, and it quits. All right. Or we can do it this way: I cover this one and it starts up. Train goes by, gets over this one, train clears, it goes out. So it works from either way, sort of. But that's the idea. And you know, there's a program in here I did a couple days ago when I finally decided I better quit monkeying with it and just run it after I smoked out some stuff.
Cheaper than an engine though.
Yeah, buddy. Yeah, they were cheap anyway. They were just a little flat laid back, but still. Yeah, Rick.
I've been doing this since probably 2004. I'm the geek. I have a master's degree in computer science, so I look at it from a different perspective. And I like the railroading stuff, don't get me wrong, but if you want to learn more about the programming, or if you want to do something different than the off-the-shelf stuff, I'd be glad to take you under my wing and see what we can do.
Thank you. Yeah.
Careful what you wish for.
I don't guarantee it'll work.
This is cool. At any rate, you get the idea. April 2016, I set this aside when I first saw it. There's an article in here where a guy took a house, a HO scale house, and animated the house. Lights come on and off, the TV goes on and off, there's voices from this room or that room. Doorbell rings, the porch light comes on, and there's a woman standing on the porch. And in each one of these sequences, there's some voices that play. And it moves from one thing to the next. It takes about 4 minutes to run through the whole program, and then it stops. It's set up to do a push button start. There's even a man and a woman dancing in the living room to music in one. And it steps through each of these animations, and they're all, and then here, if you want to see a C++ program, here's the program to do this. Eventually, this will be on my layout in some version. Modern version, they use video from old 50s TV shows and stuff. But this is what a C++ program looks like if you want to check one out. This is fairly involved because it has so many different things. It has sound, animation. It runs a motor. It runs, like I said, through several different lighting sequences, and you know, the TV flicker, that sort of thing. It's all in here. That's one thing that it'll do. Yeah, Bill.
I just looked at a starter kit, Arduino starter kit on Amazon. It's $25, and if you're a Prime member, it can be at your front door tomorrow.
There you go.
That's the way I roll.
You know, none of this stuff I got up here is stretching the truth, okay? If anything, it's a little wide on purpose, okay? As far as availability and cost and that sort of thing. So you can stick your toe in the water for cheap, and if you're like me, you get bit, then you get 2 boxes full of stuff. But it's a lot of fun. Once again, any questions? Or hold you guys too long? We got a layout we need to go see if you want to.
Very good.
Thank you.
Right.